Hi, in this video I would like to solve a couple of important SAT math questions that typically appear in the test. The first one deals with the topic of powers and exponentials. And one must know the properties of exponentials. So some important properties we need to remember. If you have a to the power of m times a to the power of n, so you have the same base, different exponent, then it's multiplication. Then you have the same base to the power of m plus n, so you can add the powers. Okay, so you have to remember that. So some people, you have to be careful that a to the power of n plus a to the power of n is not equal to a to the power of 2n. When you add, okay, you assume that this is an object, capital A, and this is the same object, capital A. So a plus a is equal to 2a. So which is equal to 2a to the power of n. So in this case, as you can see, you have 2 to the x repeated 4 times. So this can be written as in a compact form 4 times 2 to the power of x equal to 2 to the power of 16. Now remember this formula. 2 to the power of 16 can be written as 2 to the power of 2 plus 14 equal to 4 times 2 to the power of x. Now, according to this property, we can separate this to 2 to the power of 2 times 2 to the power of 14, and this will be 4 times 2 to the power of x. Now 2 to the power of 2 is just 4. So 4 times 2 to the power of 14 equal to 4 times 2 to the power of x. If you compare both sides, 4 and 4, 2 to the x and 2 to the 14. So from here we can see clearly that for both sides of the equation to be equal, x must equal to 14, and that's the answer. Question 2. The length of two sides of a triangle are 4 and 9. What is the greatest possible integer length of the third side? So let's draw. The best thing to do first is to draw a triangle. All right, so we have A, B, and C, and this has an angle, not necessarily to be a right triangle. So A is equal to 4, C equal to 9. We need to find the largest value of B such that A is 4 and C is 9. So remember the rule of in any triangle, the sum of the length of any two sides of a triangle is always greater than the length of the third side. So here this means that A plus C must be greater than the side B. So A is 9, A is 4, so that will be 9 plus 4 is greater than B, which means that 13 is greater than or equal to B. So the greatest possible integer length of the third side is that B equal to 13. And that's it. So this sentence can be interpreted mathematically as the following inequality. So A plus C must be greater than B. This is strictly greater than. It's not, there's no equality here. So A is 4 plus 9 greater than B. So B is less than, strictly less than 13. So what is the greatest possible integer? Less than 13. So the greatest possible integer less than 13 is 12. So now if you put B as a 12, now you can apply this rule to any three sides. So we know that A plus B equal to 4 plus 12, which is 16, which is greater than C. So A plus B is greater than C, which is 9. So this is correct. And you have B plus C equal to 9 plus 12, which is 21, and this is greater than A. So all these three conditions apply, then this triangle exists. And that's it. Here in question number 3, they're talking about a car that traveled a distance of 10 miles at an average speed of 30 miles per hour, and then traveled the next 10 miles at an average speed of 50 miles per hour. The question is, what is the average speed in miles of the car for the whole trip, the 20 miles? Now here we have to be careful. There's a common mistake that students who take this test fall into. People think that the average speed of the whole trip is equal to S1 plus S2 divided by 2. And this is wrong. Why? This goes back to the definition of the average speed. So the average speed, so assuming that you have a car traveling from point A to point B in time equal to t, and distance is d. So the average speed, because we don't know the instantaneous speed at each point or between A and B, then the average speed is equal to the total distance traveled divided by the total time took the car to cross the whole distance. So the total distance between A and B and the total time from A to travel from A to B. So in our scenario, if that's point A and that's point B, then we know that the total distance is equal to 10 plus 10, which is equal to 20 miles. Now we need to calculate the total time. To find the total time took the car to travel from A to B is we know that speed, remember, is equal to distance divided by time. So in this case, the time is simply related to the distance and speed using the following equation. So the total time, it's the first trip, the time took the car to cross the 10 miles, plus the second time, which corresponds to the time took the car to cross the second part. So T1 is equal to D1 over S1 plus D2 over S2. And the first distance, D1, is equal to 10 miles divided by 30 plus 10 miles divided by 50, the speed. So this is 1/3 plus 1 over 5, which is equal to 8 divided by 15, using common denominator. So you multiply by 5, you multiply by 5, you multiply by 3, you multiply by 3. So 3 plus 5 equal to 8 divided by 15, the common denominator. So the average speed in this case equal to the total distance, which is 20 miles, divided by the time, 8 over 15 hours. So that will be equal to, what happens is, this is 20 over 1 times the reciprocal of this fraction, which is 15 over 8. So we can simplify. This is 2 times 4, and this is 5 times 4. So we have 4 and 4 common factor. So we have 15 times 5, which is 75 divided by 2. And the answer is 37.5 miles per hour. And that's the answer. So the answer is not 40 as someone may expect. Now, in SAT, usually they bring questions that can seem to be having a long solution. However, if you find a trick, it may simplify the whole solution. So in this example, we have a case where the two distances, 10 miles and 10 miles, they are equal, but we have different speeds. So if you call this distance D, D1, this is distance D2, this is S1, S2. So in this case, we have D1 equal to D2. Okay, and in this case, one can show that the average speed, so if the time took this car to go from this point to that point in T1 seconds, or t1 hours. This is from this point to that point in t2 hours. Then the total time, then the total average speed is equal to the total distance traveled, so it's d1 plus d2 divided by the total time traveled, which is t1 plus t2. And remember that S1 equal to d1 over t1 and S2 equal to d2 over t2, which means that I can write t1 as d1 over S1, and here I can write t2 as d2 over S2. So in this case, substituting these values of t1 and t2 here, first of all, we know that d1 is d, d2 is d, divided by t1, which is d1 over S1. d1 is d over S1 plus d over S2. And then you will have 2d here, and then if you take d here as a factor, you will have 1 over S1 plus 1 over S2. Now d with d cancels out, and then here you can do common denominator, so that will be 2 divided by S1 times S2, common denominator, and this will be S2 plus S1. So now this is equal to 2 times the reciprocal of this fraction, which is S1 times S2, divided by S1 plus S2. And then the final answer is 2S1 S2 over S1 plus S2. And that's basically the total average speed. It's a special relationship that, if you remember, you can use it only if you have two distances which are equal, d and d, and two different speeds or any speed. It can apply to any speed, S1, S2. So in this case, if you test it, so 2 times, the first speed is 30, the second speed is 50 miles per hour, divided by S1 is 30 plus 50, and the answer will be 2 times 150 divided by 80. So again, this 0 cancels out. 2 with 8 will be 4. And of course there's an extra 0, so that will be equal to 150 divided by 4, which is equal to 37.5 miles per hour. The same answer.